Okay, I am sorry that I'm not there for you guys today. Excuse me, I am trying to do this as a screencastify, so I'm not able to pause it as easily, so if I make a mistake, I apologize. So you should be looking at this handout. At the bottom of mine, notice it's page 87. It will be one that you'll have to fold and put into your notebook, sideways, folded in on page 87. So we are going to be solving exponential equations using logs. So you'll notice that x is in the air, and we've been able to solve some questions like this. So for example, you don't have to write this down, but like if it was 5 to the x equals 25, that you guys are supposed to be able to solve, and it should be x equals 2, right? Because 5 squared is 25. Remember, when it's a video, you can pause it anytime to catch up. But because 5 times itself to get 8 is definitely going to be a decimal, and I don't let you use calculators, first of all, but right now, all you'd be able to do is guess and check until you got as close as possible to 8. But we've been doing something this whole time that I'm going to write on the side. So we've been doing log base b of a equals m. So we've been solving these questions. We did a warm-up like this a few days ago, and we've been taking them and we've been changing it to an exponent problem. Circle the b to the m, and it equals a. So we've been going this direction a lot. Since last chapter, we've been doing that. But since I have an exponent problem, and x is in the air, that's why it's an exponential problem, because x is in the air, the only way for me to get it down to the ground is to go this direction and change it from an exponent problem to a log problem. So see how b has the exponent on it? That's going to be your little subscript, your base. The b and the a are on opposite sides, so they need to be on the same side now, and then it's going to equal your exponent. So let's rewrite number 1 from exponent form to log form. So I know it's going to be log. The number that has an exponent on it is 5, so that's the base. So that's the base of my log. It's of 8, and it equals the part in the air, the exponent. Well, because when we solve, we are trying to get x alone, and we just got x alone, this is the solution. If I let you use a calculator, you'd get some crazy decimal, but I don't let you use a calculator anyways, so that's the solution. Just like when the answer is root 7. You don't go get a calculator and figure out what it is, you just leave it as root 7. Sorry about that. So that's the answer to number 1. So same idea on number 2. Obviously the exponent has a little bit more going on, but it is a number raised to a power, and it's all alone and ready to go. You'll see what I mean in the next example. So go ahead and write number 2 as a log problem. So switch it from an exponent to a log problem. So the number that has the exponent on it is 3. So 3 is my base of 7, and it equals the exponent. It equals x plus 1, right? The exponent is what it equals. This time I did not get x alone yet, so you have to finish solving it for x. But now that it's down on the ground, it's not up in the air anymore, to get x alone I would just minus 1. But you can't actually subtract the 1 from the 7, so it's just going to look like this. Log base 3 of 7 minus 1. And once I have x alone, I'm done. So there's number 1 and number 2. Always pause it if I'm going too fast. Number 3, notice the piece with the exponent on it. It's not alone yet, right? It's got this times 2 in front of it. You can never change the base. This is 6 to some power. It needs to stay 6 to some power. So you have to get it alone. So if it's 2 times 6 to some power, I need to divide by 2 to get that alone first. So now we're getting into one more step, right? You got to get it alone first. And the problems up above, they were already alone. Now it's alone. I have an x in the air that I want in the ground, so I'm going to change it to a log problem. Figure out what your base is. So the base has the exponent on it, so log base 6 of 4, and it equals the exponent. Then see what you need to do to finish getting x alone. So to finish getting x alone, I'm going to add 3 log base 6 of 4 plus 3 equals x, so I am all done. This is my answer. Remember that you can't actually add these two numbers. Okay, we're adding a step. That problem added a step, and the next problem is going to have another step as well. So again, my x is in the air. I have 9 to some power, but it's not alone yet. It has a minus 4. So you need to move that to the other side and get it alone first. So add the 4. Now the exponential part is alone. I can change it to a log. See if you can change this one to a log. And then you have a little bit more math to do to finish solving for x. Minus the 5. You can't actually minus it, so you'll get a little equation. Log base 9 of 7 minus 5 equals x, or is the answer. Okay, let's look at the last two. I know number 5 is written on your paper. I added number 6. Remember, you can pause this anytime. So we've got a lot of work to do to get this alone. X is in the air. 2 is my base. I need to get that alone first. So start furthest away from the 2. So add the 4. Remember, you can't change the 2. So it's not 5 times 2. That doesn't work. So instead, you need to divide it over to the other side. Now it's just like the ones at the top. Change it to a log problem and see if you can finish solving for x. Pause the video if you need to. Log base 2 of 3 equals 1. That would be the hardest thing you should expect to see on the test. So if you're good with number 5 or problems like number 5, you should be good. Number 6 would be the hardest thing you could expect to see in a worksheet, right? So we want to make sure we can get our assignment done as well. So start getting the part with the exponent alone. So in this case, you'd have to add the 5 first. It's still not alone, so divide by 3. And notice this time it doesn't divide evenly, which is perfectly fine. We'll just leave it as 7/3. You don't put decimals into logarithm equations, so we'll just leave it as 7/3. That is stuck together from now on. Now it's ready to be rewritten as a log problem. The base is 2 of 7/3, and it's going to equal 2x plus 1. So notice this time our exponent is a lot more complicated. Well, actually, it's just one more step. So I'm going to have to do 2 things to get x alone. Minus the 1 first, just like you would always. And then to finish getting x alone, you have to divide by 2. So x is going to equal, you can't actually do any of that, so you just write it out. Log base 2 of 7/3 minus 1 all divided by 2. And that's the answer. So this is going to go on page 87 of your notebook. And then we have one more page we need to talk about. This one's going to go on page 88 of your notebook when you're done. Same thing, it's going to need to be folded. So we are going to solve logarithm equations. So now we're going to use everything we've learned about logs to be able to solve them. So hopefully it would make sense to you that if I have log of x equals log of a. Well, first of all, notice that the bases match, right? They're both imaginary 10s. That has to be the case. It will always be the case. So if I know log of something equals log of something else, then logically, wouldn't the something and the something else have to be equal? So that's going to be an important property, especially for the first ones. But that only works if you have a single logarithm equal to a single logarithm. So notice on number 1, I have a single logarithm on the right-hand side, but I have 2 logarithms on the left-hand side. This is why we learned how to condense logarithms. So you have your notes on condensing logarithms. We did them in stations and we did them on Friday. So for logarithms, plus means multiply. So I'm going to have log of 5 times 8 is 40 equals log of x. Now I have a single logarithm equals a single logarithm, so logically, x must equal 40. But it only works if you condense. And remember that plus means multiply, and that logarithm, now I have the hiccups, sorry, that logarithm does not disappear. It doesn't disappear until you have 1 on each side, then you can cancel them out, and you get 40. So see if you can do number 2. It's a single logarithm on the right-hand side, so I'm good with that. Condense the left-hand side. So plus means multiply, so it's going to be log of 3 times x. Now that I have a log of something equals a log of something else, you can set the something and the something else equal, and then finish solving, right? You're always trying to find x, divide by 3, x equals 5. Okay, adding a little bit to that. Remember when you're condensing that we always look for coefficients first. There weren't any in 1, 2, but there is a coefficient in number 3. Remember, when it's a coefficient, you float it up and you make it an exponent. So you do that step first. Log of x is not changing. Minus, this is going to be log of 3 squared, which equals log of 5. I only changed one thing. I floated up the exponent. Now, what is 3 squared? Well, 3 squared is 9. Okay, we dealt with the exponent. Now we need to use laws of logs. Subtraction means divide. So you're going to have log of x divided by 9 equals log of 5. Once you have log of one thing equals log of one thing, the x over 9 must equal the 5, and then you can finish solving. So multiply both sides times 9, x is going to be 45. The logarithms do not disappear until you have one of each. On the next step, they disappear. Okay, we also know some other stuff about solving for logs, right? You already know how to do number 4. If it's log of something equals a single number, we can rewrite it as an exponent problem. This is really x to the 3rd power equals 125. This is one of the numbers you're supposed to memorize. So something cubed makes 125. That something must be 5. Same idea on number 5. See if you can get started on number 5. So it's a log. Let's write this on the side as one of our rules. If you have log base b of a equals m, you can always rewrite it to be b to the m power equals a, and that might help you. So for this one, 2 to the 7th power equals 3x. 2 to the 7th is not one I told you to memorize, so you can leave it like 2 to the 7th, but you have to finish solving for x. So divide by 3. X equals whatever 2 to the 7th over 3 is. Same idea in number 6. You have log of something. I know the something is a little more complicated, but it's still log of something equals a number. So we're going to rewrite it as an exponent problem. 4 to the negative 1 equals the x minus 3. Remember, negative exponents, put it on the bottom. 1 over 4 equals x minus 3. And then you have to finish solving for x. Add the 3. Add the 3. In this case, I feel like mixed numbers is the easiest way to write this. 3 and 1/4, or 3.25, or however you want to write the answer for x. Okay, number 7. So let's talk about what we've been doing up here. When you have a single log equals a single number, you can change it to an exponent. On number 7, I have 2 logs equals a single number. So again, you need to use your condensing rules. Condense the left-hand side down to a single logarithm. So subtraction means divide. Now you have a single logarithm equals a single number. Imaginary base of 10 squared equals 6 over x. 10 squared is 100. Multiply by x, 100x equals 6. Divide by 100, and x equals 6 over 100. You don't need to reduce. You can just leave it as 6 over 100. So last one, number 8. Coefficients. When we condense, we always look for coefficients first. Float those up. Seven squared is 49. I need to condense the left-hand side down to a single log. Plus means multiply. 49m is all I can do when I multiply that. Now I can rewrite it as an exponent. 4 cubed equals 49m. 4 cubed is 64. To get m alone, we divide by 49. M is going to equal 64 divided by, make sure you can read yours, 64 divided by 49. And that's the answer. So there's 3 types of logarithms you can expect to see. The top ones, where every single term has a logarithm attached to it, and you're going to condense, and then the logs will cross out after you condense. Then there's the ones where maybe there's a couple logs and one real number. You're going to condense and then change it to an exponent problem. And then there's the other page where there's no logs in it at all, but the only way to get the exponent down to the ground is to rewrite it as a logarithm. So again, the first one is page 87, the last one is page 88, and then you should have been given a third handout that you are to work on. Don't expect to use this in the handout. The handout is stuff you learned last week. And then